This video we are going to cover divergence of a vector field, divergence theorem and its example. Definition: divergence given the vector field f is equal to mi plus nj plus pk. The divergence of a vector field f is a scalar function. Divergence of f vector is equal to del m by del x plus del n by del y plus del p by del z. So one more definition of divergence f is equal to del dot f vector. Then solenoidal vector field. A vector field f is called solenoidal vector field if divergence of f is equal to 0. So problem: show that the vector field f is equal to x square y I minus 4z cube y minus x y square minus z to our 4 k is solenoidal. So given that f is equal to this, and we'll calculate divergence of f del dot f in this way. So we'll get this thing, and simplifying this will find divergence of s equal to 0, and therefore the vector field f is solenoidal since divergence of f is 0. Then divergence theorem, statement of divergence theorem in 3 dimension. Let f be a vector field whose components have continuous first partial derivative, and let S be a piecewise smooth oriented closed surface. Then double integration f dot n vector d sigma is equal to triple integration divergence of f vector dv, where d is the region enclosed by S. We'll see one example. Use divergence theorem to evaluate double integration f dot n vector d sigma over surface S, where f is equal to xi minus yj plus z square minus 1 k surface S, closed cylinder formed by surface S is a closed cylinder formed by the surface z equal to 0, z equal to 1, x square plus y square equal to 1. So to solve this double integration, we'll use the divergence theorem. Double integration is equal to this triple integration del dot f vector dv. So first of all, compute the divergence, which is equal to 2z, and then volume, right circular cylinder, x square plus y square less than equal to 4, and z lies between 0 and 1. Switching to the cylindrical coordinate, x equal to r cos theta, y is equal to r sin theta, and z equal to z. So in cylindrical coordinate, del dot f vector is equal to 2z, and dv, therefore dv is equal to r dr d theta dz. So triple integral become triple integral 2z dv, putting the value of del dot f here. So this will be the integral, and we'll solve this integral step by step. So we'll get here r when we solve this with respect to z, and next integral will solve with respect to r, that is equal to 8 by 3, and then we'll with respect to t theta, which is equal to 2 pi. So putting all this value here, we'll get 2 pi into 8 by 3, so which is equal to 16 pi by 3. So final answer is 16 pi by 3. Next example, state divergence theorem and use it to find the outward flux of f is equal to y minus xi, z minus yj, y minus xk across the solid sphere x square plus y square plus z square less than equal to 4. So divergence theorem, double integration is equal to this triple integration. So first of all, we have to compute the divergence. So computing divergence, we'll get here minus 2, and volume of sphere x square plus y square plus z square less than equal to 4. The radius is here equal to 2, so volume is equal to 32 by 3 pi. So we let the flux. So put here the value of del dot f, which is equal to minus 2 dv, and We can write minus 2 out of integral here. So this is equal to dv. So minus 2 into volume of v. So putting the volume here, 32 by 3 pi, will get 64 pi, and this is the final answer, minus 64 pi by 3. Thank you. Link of PPT is given in the description box.